Great. So as Doug said, the journey for our customers typically begin on this page, the cloud.nimblestorage.com. This is where they find all the information that Doug described right now, including pricing. And they can also sign up for Nimble Cloud Volumes, and once they have login and password, they can sign in. Now, for today's demo, I am going to demonstrate a feature that we haven't released out there in public yet. So I'm not going to click on this particular sign-in link, but rather go to our internal dev instance of cloud that I have already logged in. Let me just log out for a bit and just so from the start, right? This is where our customers will start. They'll have a login from us. I'm correct. So this is the home screen where they can see the volumes that they have created. These are the Nimble Cloud volumes that they are using or they plan to use with AWS or Azure. It doesn't matter. So in this case, there are two volumes, AWS volume and an Azure volume. Now, as part of this demo, I'm going to do two things. The first part is where I'll create a new volume and use it from an EC2 instance. To an EC2 instance and an application running inside EC2, it doesn't really matter whether it's an EBS volume or Nimble Cloud volumes, except that it's getting a whole lot of features from an underlying storage. And then I'm going to demo a second feature that is not out there open yet, which will involve Azure as well. So let's begin by creating a new volume in this case, right? And as someone was asking before, can this be done through APIs? Yes, we are a cloud service. APIs are must. But I'm going to, APIs are not as sexy in demo, so I'm going to demo through UI right now. So the first part of your volume creation process, hey, we are multi-cloud service. Which cloud do you plan to use it with? I have an AWS account. I want to use it with AWS. Fair enough. Which region are you going to hook this up to? Today we support 2 regions, but because I'm in a dev test instance, I get another extra region, which is US West 1. That's the California region. Now I have set up IAM credentials between my AWS account and my Nimble Cloud Volumes account. This allows Nimble Cloud Volumes to look inside my AWS, read-only access, and look different VPCs that I have. So I have to choose a VPC that I want to use with this for this cloud volume. In this case, I know the VPC that I plan to use, and I click Next. This is where I enter the name of the volume. Let's say demo 0728-01. And I can choose size and IOPS for the volume. The size can go as high up to 16 terabytes. And by the way, IOPS can go as high as to 50,000. The IOPS in EBS max out at 20,000. And IOPS in Azure Disk, I think, max out at 10,000 or even less. So for this demo, 2,000 IOPS. I can choose to put an application on this volume and let us know in advance what application are you going to put on this volume. This allows us in the backend to optimize certain parameters for the volume. Today we support these applications. If it's not one that you plan to use, you can choose other. Notice the difference between how we have taken an enterprise look at configuring everything. We do care what application you plan to deploy there. At the end of it, you can choose between premium flash and general purpose flash. If you are used to EBS terms, this is like IO1 versus GP2. So you can choose whichever one you want. So let's say I go with PF in this case.
And what's the limit?
Sorry?
What's the limit in the previous
limit on?
Yeah.
The limit on size?
Size and IOPS.
So it's mentioning limit on size is 16 terabytes, and limits on IOPS is 50,000 IOPS.
Okay, got it. Thank you.
The next thing is we also have a built-in snapshot protection. You can tell us how frequently you want to take snapshots and how many of them you want to retain. You don't need to write a Lambda job like you need to do with EBS or others. This is built in. We do manage retentions and schedule together. You can also choose to encrypt the volume. This is encryption at rest, which means before it lands onto storage, it gets encrypted. This comes at no additional cost, so I'm going to just choose and use it. This is the last screen. I review everything. I'm going to create, again, review an AWS, a volume for AWS, of 100 gigabytes, 2000 IOPS, with certain snapshot policy, looks good, confirm.
Now, when my EC2 instance connects to this, it's going to connect via iSCSI, right?
Yeah.
And it's going to consume that entire volume?
Yeah.
And there's no API yet?
There is API, just that I'm not demoing that API.
Okay.
Right. Good.
This is built separately from, this is not on an AWS bill, right? This is,
So the API endpoint would be separate. So you have to talk to EC2 API endpoint will be AWS. This will be an NCV endpoint. So the two different endpoints. Again, REST API doesn't matter.
no, in regards to costs.
Yeah, the billing is.
Oh, the billing, yes.
Billing is separate.
Yes.
Okay.
Yes.
Yep.
All right, so now the next step of this process is I have created a volume. I need to use it with an EC2 instance. Now, the way to do that in NCV is you go and say select the EC2 instance. We call it Cloud VM that you can attach this to. Now, I do want to point out here, you can attach this volume to more than one Cloud VMs. Why do I want to do that? Because there are many clustered applications that people tend to run, SQL clusters, Oracle racks. They need shared access to the disk. EBS doesn't give you that. Azure Disk doesn't give you that. NCV gives you that. Today, I'm just going to connect one. And I have a drop-down list. I can see a different EC2 instances that I have available on my VPC. I can choose from one. I know which one I want to use. Select confirm. So the last part of this process, and this is something that gets automated even better through APIs, is where you copy and paste a PowerShell script. It's a simple PowerShell script that is available in the downloads menu. And you go to an EC2 instance and run it. So this is my remote desktop into an EC2 instance.
So do you need to install anything within the OS from Microsoft, or is it just the native iSCSI?
It's a native iSCSI and native MPIO. Just a native supports. So
Sorry, you said native MPIO. Do you then need to have a second NIC, or?
no, just that we connect more than one sessions, just in case. Because on our end, we have multiple NICs. So you can say it's multi-paths, right?
Can you guys take advantage of like the EBS optimized, anything like that? I know that's probably EBS, but it's a different network.
That's right, but that's internal. That's EBS optimized.
Okay.
They only use a 1 gig network for their internal EBS.
Right.
They probably have a SAN of their own.
Yeah. I don't know if
tell
you
you.
can take advantage of that for this. Yeah.
No, I mean, it's AWS. They'll hide everything from you, right? So in this case, this is my EC2 instance. This is their boot drive coming out of EBS. Right? Boot drive support is just restricted because of the hypervisor design, because they use Zen, and you can't just use boot drive in there unless you play some games. So without playing any games, I'm just going to add a new data drive to this instance. As simple as copy pasting this command, it's doing iSCSI Connect for those who know iSCSI. Now, at this point, as you see here, there are two drives to this EC2 instance. One is EBS, one is NCV. Does it matter to this EC2 instance? No. For it, it shows as two block devices. Does it matter to the administrator? Of course, because you get much more durability. You get snapshots, you get clones, you get multi-access, you get replication. But for EC2, for an app developer, it's as simple as having another block device. Now, as part of this last part of this first part, is I'm going to run some I/O on this device, right? And for those who don't know this program, this is I/O meter. This is a simple I/O benchmarking tool. I'm going to run 4K random writes on this guy, and let's just get this going.
Just while that's running,
Yeah.
so could you just clarify the API situation for me? There's a couple of us who are not quite clear on the API access. So
Can we?
you do or don't have one, or it's the PowerShell script is how you connect things? How does that work?
Sorry, come again. Something else was happening.
Sorry,
there.
yeah. Could you clarify the API situation for us? So does it have a REST-based API that I can use to do all of that you were doing with your PowerShell?
It does, except that we haven't still made it public. So all this UI work is happening through API. They end up at its talking APIs.
Yep.
Very soon, next few months, we'll open it up to public. Just that we're hardening the APIs. Once you put the APIs out in public, you can't take them back. So we want to make sure those are hardened before we send them out.
Okay. So
But
this service isn't public yet. So Cloud Volumes.
APIs are not public. The service is public.
Oh, okay, so you went live with Cloud Volumes before you got the API finished.
We went live with the UI part of it.
Yep.
But the API is coming out very, very soon. Yeah.
The command, the PowerShell command you ran to connect the iSCSI device to the Windows machine.
Yes.
Would it be the same command on a different instance? Like if I went ahead to run could I run the exact same command on a different instance and it would also connect to the same volume?
No. So the command is attached to, so there's a chap we use between initiator and target, so to make sure the security is correctly set. So once you attach, you take that command and run it on that particular instance.
Okay, so I'm trying to think through the automation here in my head. Once you have an API,
you can get the command from API and run it.
But
I've got to build the EC2 instance first, and then I have to go.
Think about your CloudFormation template, right? In CloudFormation, you start your instance, and as part of that CloudFormation template, you also have this Python API that you plug in that calls NCV, gets the command, runs it, and gets it ready for you before the application guide develops.
Because there are two parts to the API. One is provisioning the cloud volumes, the back-end storage in effect, and the other part is here, the PowerShell, which is connecting to it. Is that correct? Or?
That's right. So there is one part where you create a volume, and there's a second part where you connect to that volume. Now with the APIs, you can all drive that through API. Create, connect, format, use. You see what I'm trying to say?
Yeah, it's just sequencing at this point. I'm thinking the orchestration. I've got to build the EC2 instance, then I got to go create the volume because I'm not going to pay for it until I'm ready to use it. Yeah. And then after that, I'm going to log into the EC2 instance and run the command to connect to it.
Yeah, grab the command first.
Well, I got to grab the command from the API, then log in.
Correct. So you can think of it like
it's doable.
3 API commands that you'll have to run.
Yeah. Okay.
Create, get the command, and run the command.
Okay.
Yeah. Create, get, and then run it inside the EC2 instance.
Okay, let me get this done. Let me relaunch this or something else. It's getting into some errors right now. What's to happen? Let me disconnect and connect this back for a minute.
Do you not need to format your disk?
No. Oh, yeah. No, sorry. I didn't online it. Thanks for pointing that out.
Or make it, or bring it online.
I was wondering how it's going to work.
I didn't need to format, but I had. Yeah, I know.
Not yet, it isn't.
Right.
Just say all the protections are in place. All right. There you go. All right. So as you would have seen before, we set a threshold on this volume of 2,000 IOPS, right? And because we set it to 2,000, whatever you push, it's not going to go above that. But hey, you're not stuck with that choice. Many times it happens that you started with certain application, you get more users, you need more IOPS, more capacity. With some of the cloud providers, you're stuck with the choices that you have made. In Azure Disk, for example, you take a 1 terabyte disk, you only get 5,000 IOPS. If you need more IOPS, you have to buy a new disk, or you can't just resize. But you're not stuck with that choice with NCV. You think you need more IOPS because you deployed a new application and got more users. You go back, you say actions, you say edit my volume. Let me bump this out to 3,000, a healthy 50% raise for this volume. I say confirm, and I go back, and it jumps right away to 3,000. And this is the beauty of it, that you are not stuck with a choice that you have made. And that's the theme of our overall theme. You're not stuck with AWS. You're not stuck with Azure. You're not stuck with public cloud. We let we give you all the mobility to move between clouds, change your options, change your size, change your IOPS, take snapshot, restore, it doesn't matter. And this is what the enterprise guys are used to when using storage. So that brings me to the end of the first part.
That's not necessarily what cloud guys are used to when they're using storage.
Here is the thing, right? There are two types of cloud guys. One who are born in cloud. Startups of 10 people who just started programming with cloud native apps. But you go and talk to big guys I mean, we are talking to some of the big law firms, some of the big, cloud service, some of those big service providers, some of the big telecom providers. These guys have immense amount of expertise built in running their Oracle apps and SQL apps in the way they run today. They like cloud for the agility. They like cloud for the pay-as-you-go mobility. But they don't want to tear down their apps just because Amazon wants you to use RDS. You want to go with relational database service. Why not take my existing, because it's not just that database. There are 1,000 things built around it. You look at typical enterprise deployment, around an enterprise database, there are 100 things built around it. I can't tear everything apart. Lift and shift works great for me, and that's where this plays its part. So when I say cloud, these are, as Doug was pointing out, the third stage of cloud migration, where enterprise apps are moving to cloud, ERPs, databases, your SQL servers, those are moving to cloud, and they need this facility.
But what part of cloud do those applications need? So for example, the database. So for example, for this database, I'm trying to understand why I would use this over a relational block store, for example. So if I move my database there, what you're offering me is the same as I've got on site, only it's got better disk resiliency than EBS.
Resiliency is one part, absolutely.
Is one thing.
Much better, yes.
I can connect to CPUs that float up and down because my database needs to have burst CPU for some reason. Yes, no?
So let's say your database users grow and you need more IOPS.
Yep.
Let's say you're an Azure customer. Can you do that today? No.
Okay.
You can't just add IOPS to an Azure disk today.
Right, okay.
Let's say I want to test and dev instance of my database because my dev guys want to play with current copy of database and do some, test my new application. What does it involve in EBS to create a clone of a database, right? On an EBS, cloning is an operation of take that data, put it into S3, copy from S3 into new EBS, and you get 2 volumes now. Mm-hmm. And this takes like hours to complete. Mm. And these sort of operations are not natively built into RDS. And the other part about RDS, as I was saying, is that RDS only takes care of your core database. But now you have so many applications built around it, you have to rewrite those to work with RDS. They were working with your standalone database server before, your log analytics, your BI operations. Where are you going to put those? And now this becomes an operation that...
Right. So why am I going to cloud?
You're going to cloud because you're not managing your data centers anymore. Every 5 years, you don't have to worry about, do I need to upgrade my data center?
I don't manage them now because it's in a colo. So.
No. By managing, in a sense, managing the life cycle of it, right? You don't have, even if it's in colo, you're paying someone, you still have to choose between, whether should I buy HP, ProLiant, should I buy Dell, 3 years down the line, should I upgrade to something?
It's a managed service provider, so they give me some VMs, so
before
I don't do that.
Nimble Cloud Volumes, why were you going to cloud?
That
sounds like you're questioning cloud altogether. So what?
But I am for this. So for the example you were just giving me was that I've got this database which works perfectly well in non-cloud things and I don't want to change it. Okay. And then I've got this ecosystem of applications that live around that database that I don't want to change. And I don't want to change them either. So why am I going to cloud?
Yeah.
I'm changing something, but I'm trying to understand. So I'm not changing all of these other things, but I am going to cloud.
2 things.
Why?
Agility.
What is it I'm doing?
Agility. If you need new CPU, how long does it take you to get new CPU?
Yep. Okay.
How long does it take you to get new storage? Mm-hmm. How long does it take you to add users? Pay-as-you-go model. Mm-hmm. You can spin up and spin down as much as you need and spin it down when you don't need, right? And third is actually you get much more piece of reliability from the overall cloud service tends to be more reliable because of the guarantees that they're giving, including the guarantee we are giving, than someone else managing it for you. I mean, we have talked to customers who said in their data center, a problem on the left-hand side of the data center sometimes appears to be coming from the totally right-hand side of the data center. In AWS world, in NCV world, that is completely managed for you. So again, agility, pay-as-you-go, and this peace of mind that someone else is taking care of it for you, which you said can be done by someone else, but not the first 2 things. All right, so the second part of this demo, as I was going through, is let's just stop doing I/O for a minute and format this volume as someone was hoping I would before. I initialize this disk, and I'm just going to quick format it with NTFS. While this formatting, what we have right now are two disks, one from EBS, and one will have a drive later coming from NCV. And then we'll demonstrate a new feature that is not out there in public yet, but just for you guys.
In the internet.
All right, so I got a new drive letter D colon over here. I have a file which says hello. Hello. I'm going to copy this to this D colon and just click open this. It says hello from the other side. Thanks, Adil. But anyways, sorry if you're not an Adil fan, but this is relevant in context of this demo, so I'll show you later. So let's close this and let's get back to our cloud portal. What I'm going to do now, is create a snapshot of this volume. Why do people create snapshots? Is because they want to retain the state of the volume as it was recorded before. This is in known good state. I want to record this known good state. So I record this state as my, test snapshot. Wow. Confirm. Now, imagine you taking the same snapshot in EBS, which takes 30 minutes to 1 hour to complete, depending upon your data size, because it is a background operation of moving data from block storage to object storage, EBS to S3. Similar with Azure, moving from premium flash storage to managed disk storage.
Sorry, can you take an app consistent snapshot as well?
Not yet, but we can do that on our on-prem arrays. That's something that we have to move to our cloud offering very soon. All right, so with this snapshot, there are 3 things, of course, you can do. You don't care about the snapshot, delete it, restore from that state, or this is cool new feature is you can create a clone from the snapshot. A clone is basically you create a writable snapshot, a new volume that just starts from the known good state, right? And this is where you want to create new test and dev instance. You want to try new patch on your known SQL server without disturbing your production instance. So and that very typical use case is of test and dev. So I create a new clone. On a clone, I can choose different IOPS I want to, but not just that. I can choose a different cloud provider for this clone. Maybe I'm considering migrating from AWS to Azure, and I just want to test it out, how it will function in Azure. I don't have to move my whole data. All I have to do is take a clone of my existing volume in AWS and attach it to Azure. Or I can attach it to different VPC within AWS as well. But in this case, since we haven't demoed Azure yet, I will use Azure. Let's say I want to test how it works in Azure. And in Azure world, it is called VNet. Instead of VPC, I choose a VNet I want to connect it to. I connect to a new VNet, and I confirm. It takes a few seconds to connect, and it's done. All right. So now that I have created a clone, which is, this little icon shows you it's a clone, I will now attach this clone to a VM inside Azure. Okay, I just have one VM inside Azure. I can drop down and see through Azure as well. CFD demo VM. I click confirm. I get this command that we got before. And I go to Azure now. This is my Azure VM. This one also has 2 volumes, both coming from Azure. I'm going to add an NCV volume to this. Remember, this was the clone of an AWS volume that we are now accessing in Azure. So I just got a new volume added here which says F colon. Let's open F colon and see what are the contents of F colon. Someone's saying hello to you. By the way, it's from the other side. So that's the end of my demo.
Are there any plans to add any additional functionality so that I can control things in either AWS or Azure from here? Like this clone operation might be neat, but it would be neater if I could just say, hey, I've got an instance in EC2 why don't you spin up a VM in Azure and attach this for me automatically?
Yeah, I guess APIs is the answer for that.
Okay.
Right.
Yeah, like AWS, you use Systems Manager to run that PowerShell script,
Yeah.
automatically attach the job.
Right, then I wouldn't have to do it at all.
I mean, it's there already, right?
So you could use some of those native tools, integrate into your chefs and puppets, whatever you're using, and then.
Okay.
Well, I think that, trying to think, as you were finishing the demo, I was trying to think how to formulate the question, but I think it fundamentally comes back to, are you building software to manage Nimble storage hardware, or are you building software to manage processes that enterprises would use? Because those are two different things.
I would say it's a service to start with, right? We are giving them a service, a storage service, as someone put in here.
Yeah, but I guess what just so we're clear, what I'm getting at is, are you headed down the path of disassociating software from hardware?
We're going down the path, again, I'm sorry, to the service path where we are freeing users from knowing the gory details of infrastructure. All they know is they need a storage of certain kind, a volume of certain kind, and they know this is the API endpoint, this is the UI endpoint they're going to go to and use it, right? What happens in the background is something they don't need to worry about. We figure out you specify a region, we figure out which Nimble array, in which data center this volume should go to, right?
So what I'm seeing is, I think, you're allowing people to declare what storage they need, and that goes off, so you're being declarative. Like, I need this with this throughput, this size,
That's right.
on this service. And from what you've demoed, and of course that's just a small part, people are declaring, and then your process was all the flipping back and forth and everything like that to do the actual end thing that you wanted to happen, like the clone to move over to Azure, or the volume to get mounted. Right now, so I think part of your question is, are you going to now make that process more automated? Or are you leaving that up to developers and architects, or even a third party, to make all the magic work even more automated?
So what we are going to do is going to provide APIs and wrappers over those APIs such that people can plug it into some of their existing workflows, as we were discussing here. We will, of course, enhance on a lot of the automation here.
Yeah.
And there are some plans on cutting down on that copy paste of the command, for example. We have ways to figured the ways to do that. But at the end of the day, we believe the best way is to give the control to the DevOps guys, give them all the APIs, give them all the commandlet wrappers, be it Python, be it PowerShell, whatever they want to use, and then stitch together a workflow as they seem fit. So they get, this is what they're used to with AWS and Azure, right, today. They get 10 different services and then stitch together to form their canvas of their infrastructure.
Right.
So we are another piece in their canvas.
Right, and even what's happening in Azure, and I'm not familiar with the AWS side, but the move from scripting to declarative templates and the automation and everything.
Correct.
It sounds like, I'm seeing more of a parallel to the ARM templates where you're declaring what you want, and under the covers, the person, other than maybe fiddling with the orders, because once you get so complex, you might want things to do in it.
That's right. You can extend it to that level of abstraction, and Azure is more than AWS is less on those templates.
Yeah.
Azure is more of an enterprise guy. They use
exactly.
Correct. Yes.
Exactly. Okay.